means there's a factor c squared, the speed of light squared at the end. Now, in order to create these particles and make sure that they have enough energy, we have to accelerate them up to very, very high energy inside the LHC. And that means that they are going almost at the speed of light, where we'll then collide them together, and we have this very high energy in a small space that can make these new particles that we want to find. So in order to make the beams particles, we start with a bottle of hydrogen, like the one we have here, and this contains thousands of billions of protons that are contained within hydrogen atoms. Now, those hydrogen atoms have just protons and electrons. And we inject that gas into a box, which we call the particle source, and we energize those atoms inside the source in order to rip the electrons off the protons. Those protons are then free, and we're able to accelerate them out of the source and through a linear accelerator, like the one you see next to me, and accelerate them up to sometimes a third of the speed of light before they're sent on towards LHC. Right here, you can see one of the bottles of hydrogen that was used to make protons for the LHC. We start by injecting the hydrogen gas from these bottles into a source of particles. Now, the hydrogen in these bottles is made up of just protons and electrons, and that's ideal for creating just the protons that we need to collide in LHC. We start by injecting it into the source, and then we use an electrical discharge. Now, that's something just like you'll find in a neon tube or a fluorescent tube that you might have in your house. The electrical discharge there accelerates electrons and allows them to knock the electrons off the hydrogen atoms. We then have these protons free in a plasma, and we can extract them out of the source and accelerate them by using electric fields on towards LHC. So in order to make the protons that we need in LHC, we have to start with a source of particles. And we do that by taking a hydrogen bottle, like the one you see here, and taking the hydrogen gas from it and injecting it into a particle source. Now, the hydrogen gas is made up of just electrons and protons, and it's those protons that we want to rip out of the hydrogen atoms in order to create a plasma, and then accelerate out those protons through lots of kicks with electric fields along the linear accelerator up to about 1/3 of the speed of light before they head off through the rest of the accelerator chain off towards LHC. Now, inside this bottle, there are already thousands of billions of protons. And yet within LHC, there will just be maybe 100 billion protons per bunch traveling around the LHC making collisions. One of the things I really love about being at CERN is that when you have a difficult problem, sometimes you can find really the world expert in that problem at CERN. And they're so enthusiastic about helping you and making sure that I can find exactly the right solution I need to make the best particle source that I can make at CERN. And that enthusiasm you also see in people from outside CERN. When I tell them what I do, often their eyes really light up and they really want to know more about the physics we do at CERN and how we make the particles and how we produce the new energy particles on the frontiers of physics. And if you're enthusiastic about it, you could also think about a career at CERN. We take lots of students, and if you have an interest in physics, and not just physics, it will also be mechanical engineering, electrical engineering. We have lots of different possibilities at CERN. So look at the CERN website and see if there's something that interests you.